Hello students, welcome to chemistry classes. So under this redox reactions, today we are going to discuss the oxidation number concept of oxidation and reduction. First of all, you must know what is oxidation number or oxidation state. Oxidation number is otherwise known as oxidation state. Simply say, the residual or apparent charge possessed by an atom is called oxidation state. That is, residual or apparent charge possessed by an atom. For example, sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. It consists of one electron in their valence shell. Suppose it lost one electron from the valence shell, it becomes Na plus, monovalent ion. So this is the residual charge possessed by an atom by losing electron or gaining electron. Cl 17, 1s2, 2s2, 2p6, 3s2, 3p6, 3p5, one electron less to attain the stable configuration. So it gain one electron means Cl minus. So this is the residual charge of an atom or ion having either positive or the negative charge by losing electron or gaining electron. This state is said to be oxidation state of the certain elements. How to define oxidation and reduction by using this oxidation number concept. Before that, you must know how to assign the oxidation number of various elements present in the given molecule. So this is some of the rules which is used to assign the oxidation number. First of all, the first point, I will explain the points individually. The oxidation state of element in the free state. Oxidation state of element in free state or in molecular state. Molecular state is assigned as 0. The point is, the oxidation state of element in the free state or in the molecular state is assigned as 0. For example, hydrogen. Hydrogen in the free state, its oxidation state is 0. Chlorine in the molecular state, its oxidation state is 0. This is the first point. Second point, hydrogen. Hydrogen is assigned as oxidation state of +1 in compounds except metal hydrides. Metal hydrides. So this is the point. Hydrogen is assigned as oxidation state of +1 in a compounds. For example, water is a compound. Here two hydrogen atoms are there. You find out the oxidation state of oxygen. We know the oxidation state of hydrogen in this compound. Two hydrogen atoms, 2 into 1, +1. 2 into +1 plus oxygen is assigned as x, that is equal to 0. So 2 plus x is equal to 0, x is equal to -2. So the oxidation state of oxygen in water is -2. But in the case of metal hydrides, for example, sodium hydride. Metal hydride, the oxidation state of hydrogen is -1. You know, metals are electropositive in nature. For such case, the oxidation state of hydrogen is assigned as -1. For example, calcium hydride. You find out the oxidation state of calcium, that is x. 2 into -1 equal to 0. X minus 2 equal to 0. X is equal to +2. Oxidation state of calcium in calcium hydride is plus 2. So, for this case, oxidation state of hydrogen is assigned as minus 1. So, in the concluded the second point, hydrogen is assigned as oxidation state of plus 1 in all compounds except metal hydrides. In metal hydrides, hydrogen is assigned as oxidation state of minus 1. The oxidation state of fluorine in all compounds are minus 1. Fluorine, we know that fluorine is the most electronegative element which belongs to group number 17. It always shows minus 1 oxidation state. You remember in any places, any question asked like this, the oxidation state of fluorine is assigned as minus 1. Whether metallic halides or non-metallic halides, etc. Whatever may be the compounds, fluorine shows the oxidation state of minus 1. And the oxidation state of cation or anion, cationic compounds or anionic compounds. For example, NH4 plus is a cationic complex. SO4 2 minus is a anionic complex. The overall charge is equal to, overall charge is taken as equal. For example, you assign the oxidation state of nitrogen. Nitrogen is taken as X, 4 hydrogen atom, 4 into plus 1, overall charge equal to plus 1. Suppose calcium 2 plus is merely given Ca2 plus ion. What is oxidation state of calcium 2 plus? Is a plus 2 is the oxidation state. The charge itself is the oxidation state of calcium. F minus means minus 1 is the oxidation state of fluorine. Here SO4 2 minus, you assign the oxidation state of sulfur. It is X, oxygen 4 into minus 2, that is equal to minus 2. The charged compounds, the overall charge is equal to, we are taken as equal to constant charge, either positive or the negative, or simply the ionic compounds, either positive ionic compounds, positive ion or the negative ion, the overall charge is equal to the oxidation state of the concerned element. The next is oxidation state of oxygen. Oxidation state of oxygen is assigned as minus 2 in all compounds except peroxide and superoxide. Peroxides and superoxide. The oxidation state of oxygen is assigned as minus 2 in all compounds except peroxide or the superoxide. For example, K2Cr2O7. We are find out the oxidation state of chromium. We know that potassium K plus star 2 into plus 1 plus 2 chromium 2x plus 7 into minus 2. Oxygen is assigned as the oxidation state of minus 2. That is equal to 0. 2 plus 2x minus 14 equal to 0. 2x minus 12 is equal to 0. So, 2 potassium 2 into 1 2 chromium 2, 7 into 2 minus 14. So, 2x minus 12 is equal to 0. X is equal to 12 by 2. Here x is equal to plus 6. Chromium, oxidation state of chromium is plus 6. Okay. In the peroxide, hydrogen peroxide. So, we assign the oxidation state of hydrogen. So, 2 into plus 1 or 2x plus 2 into minus 1. The oxidation state of oxygen in peroxide is minus 2 equal to 0. 2x minus 2 equal to 0. 2x is equal to 2. X is equal to plus 1. We know that oxidation state of hydrogen is plus 1. So, the oxidation state of oxygen is assigned as so minus 2 in all compounds except peroxides and superoxides. Suppose this oxidation state may be vary. Listen, let us consider the compounds OF2 and O2F2. You find out the oxidation state of oxygen X. We know that fluorine is assigned as oxidation state of minus 1 in all compounds. 2 into minus 1 equal to 0. So, X is equal to plus 2. Oxidation state of oxygen in oxyfluoride, oxygen difluoride is plus 2. O2F2, 2x is equal to 2. X is equal to plus 1. So, oxidation state of oxygen may varies from compounds to compounds. The normal compounds, oxygen shows the oxidation state of this minus 2. Some other compounds, peroxide, this oxidation state is minus 1. Oxygen difluoride, the oxidation state of oxygen is plus 2. Dioxygen difluoride, the oxidation state of oxygen is plus 1. And also the oxidation state of neutral molecules, that is helium, helium, neon, argon, krypton, xenon, etc. This oxidation state may be 0. So, binary compounds, oxidation state of binary compounds. For example, potassium iodide is a compound. You assign the oxidation state of iodine. We know the oxidation state of potassium plus 1 plus X is equal to 0. X is equal to minus 1. Iodine having the oxidation state minus 1. So, the binary non-metallic compounds, metallic compounds, non-metallic compounds, interhalogen compounds, the oxidation state is assigned depends upon the nature of the compound. For example, I will give one example of interhalogen compounds, ClF3. You assign the oxidation state of chlorine, X plus 3 into fluorine minus 1 equal to 0. So, X minus 3 equal to 0, X is equal to plus 3. Now, you have one doubt, halogens are more electronegative, then why halogen shows positive oxidation state? This is one important question arises in each and every people's mind. You remember in the halogen family, fluorine only shows negative oxidation state in all compounds. All other halogen, chlorine, bromine and iodine shows both positive as well as negative oxidation state. Positive oxidation state as well as negative oxidation state depends upon the nature of the compounds, Now, I would like to give some example to calculate the oxidation state. Simple example for calculating the oxidation state. So, before that, based on the oxidation number concept, what is oxidation and what is reduction? A chemical process in which the oxidation number is increased. Increase in oxidation number is called oxidation. A chemical process in which decrease in oxidation number is called reduction. A process in which increase in oxidation number is called oxidation. Decrease in oxidation number is called reduction. Now, you go through all the three definitions of oxidation and reduction. Classical concept of oxidation. Addition of oxygen is called oxidation, removal of oxygen is called reduction. Addition of hydrogen or removal of oxygen is called reduction. First classical concept. And then electronic concept. Loss of electron is called oxidation, gain of electron is called reduction. Oxidation number concept. Increase in oxidation number of a particular process is called oxidation, decrease in oxidation number is called reduction. And what is oxidizing agent and what is reducing agent. An oxidizing agent, a reagent which can increase the oxidation number of an element, which can increase the oxidation number of the element in a given substance is called oxidizing agent. The oxidizing agents are otherwise known as oxidants. Oxidants. What is reducing agent? A reagent in which can decrease the oxidation number of the element in a given substance is called a reducing agent. The reducing agents are otherwise known as reductants. Now, I will give simple example how oxidation and reduction can take place in a simple process. Oxidation and reduction can take place in a simple reaction by using the experiment equation. Hydrogen sulfide reacts with bromine, gives hydrogen bromide and sulfur. Hydrogen bromide and sulfur. Let us consider this reaction. You assign the oxidation number of sulfur, bromine, here bromine and sulfur. So, two parts we are taking, hydrogen sulfide. First you calculate the oxidation number of sulfur. 2 hydrogen atoms are present, 2 into plus 1 plus x is equal to 0. So, x plus 2 equal to 0, x is equal to minus 2. The oxidation number of sulfur is minus 2. Bromine in the molecular states, its oxidation number is 0. Hydrogen bromide, the oxidation number is minus 1. You can calculate hydrogen 1 plus x is equal to 0. X plus 1 equal to 0, therefore x is equal to minus 1. Sulfur in the elementary state, its oxidation state is 0. So, now comparing the oxidation number. Sulfur, the oxidation number changes from minus 2 to 0. Minus 2 to 0. Increase in oxidation number. Increase in oxidation number. Increase in oxidation number is called oxidation. Bromine changes from oxidation number 0 to minus 1. Decrease in oxidation number, that is called reduction. So, this is the easiest way to predict whether it is oxidation or reduction takes place. Here both oxidation as well as reduction takes place. Hence, this reaction is a best example for redox reaction. So, both oxidation, increase in oxidation number, here decrease in oxidation number takes place. So, in this module, we learn about oxidation number. What is oxidation number? What are the important rules for assigning oxidation number? And how to predict the you have some ideas to predict the oxidation number. Now, you are positioned to say find out the oxidation state of underlined element carbon dioxide MnSO4, here S, sulfuric acid H2SO4, sulfur, HNO3, nitrogen, K2Cr2O7, chromium, Cr2O7 2 minus, CrO4 2 minus, chromium. For all this underlined element, you can calculate the oxidation state. So, I hope all these concepts are understood by each and every people. If you have any doubts, you may ask. Thank you.